Today we're going to have a look at literal equations. So what is actually the point of doing this section? Well, the best way to think about it is in terms of scientific formulae. So if I have a look here, I've got the scientific formula for kinetic energy, which is a half times the mass times the velocity squared. So if I was in a situation where I had the mass and I had the velocity and I was trying to find out the kinetic energy, that would be all very well, because I would simply substitute those values into those variables and I would be able to work out what I'm looking for. The same here if I was looking at pressure, which is force over area. If I had the force and I had the area, I would be able to work out the pressure. But what if in a situation that involved kinetic energy, I knew what the value of the kinetic energy was, and I knew what the velocity was, but I didn't know what the mass was? In that case, I'd be trying to find out the value of the mass, which is not the subject of the formula. In other words, it's not on its own on one side. So before I substituted the values in for the things that I do know, I would need to first manipulate this formula mathematically using mathematical rules to get m on its own on one side, and then I would substitute in those two values and I would be able to find out the mass. So that's what we're trying to do with the literal equation, is basically, as I've said here, change the subject of the formula. So when you get the thing that you're looking for on its own on one side, it will not be equal to a value. It will be equal to something that contains other variables, because those are the variables you would then substitute with the values that you know. So let's have a look at, first of all, making x the subject of the formula in this situation. So just think of it in terms of what we've been doing. We've got an equation, we've got variables in the denominator, we've got denominators, so we're going to go about it in exactly the same way that we would have before, and we're going to eventually try to isolate x and have it on its own on one side. So because they're denominators, we're going to start off by thinking of what the denominator is, the LCM, and it has a b and it has an x, so therefore our LCD is going to be bx. So I'm going to multiply every one of the three terms by my LCD. When I multiply this term by bx, the b's are going to cancel and I'm going to be left with x. I already have a 2b here, and then think of when I multiply this by the LCD, the x's are going to be cancelling and I'm going to be left with a b. So I'm going to, well, let's do it long ways so you can see exactly what I'm saying. I could have in my head straight away said this is going to be 2b squared, but let's put it like that so that you can follow all the steps. Because this term doesn't have a denominator, nothing can cancel, so it's going to be 2 times the LCD, in other words, 2bx. Right, sorting this out, as we said, it's going to be 2b squared. And now you have to try and just keep focusing on what you're trying to make the subject of the formula. And at this stage it can get a bit confusing because there's so many variables and things. So just think, any term that contains an x must go to one of the sides. So I've got an x there already, I'm going to leave it there. And then this also contains an x, so I'm going to bring it across. It was positive, it's going to become negative. This was positive here, it's going to go across and become negative, and it's going across because it doesn't contain an x. Okay, now be very careful here. You can't subtract these two, because this has got just the variable of x and that's got the variables bx. So what I can do instead is I can take out a common factor of x to I'm trying to isolate x as much as possible. So by taking out a common factor, then x divides into x once, and here once x is divided into that, I'm left with 2b. This side I can't simplify at the moment. Now I want to have x completely on its own, so I'm going to divide by anything that's multiplied by x. Remember, a bracket means multiply, and the inverse of multiplication is division. So I'm going to divide that. If I just write it down like this, because it's completely in the denominator, it implies that it has brackets. So those would cancel, and I'm left with x is equal to negative 2b squared over 1 minus 2b. And don't be tempted to cancel these b's or cancel these 2's, because you would be cancelling across a negative sign. So now, in other words, if you were trying to find the value of x in this formula and you knew the value of b, once you've made x the subject of the formula, would substitute the values of b in, and you would be able to find the overall value of x. So I have successfully made x the subject of the formula. Let's take a formula from financial maths now, because this happens very often in financial maths. We know that this is a formula for compound interest, but very often we are asked not to find the a value, but to find the I value or the n value. And in that case, we need to change the subject of the formula. So in this case, I'm going to try and change the subject of the formula to the I, because very often we asked to find what was the interest rate. Okay, so first of all, the thing to realize here is which inverse operation am I going to use first. So considering that I is inside the bracket, you can't get rid of the 1 from the side because it's very attached to the I being in the bracket, but the p is being multiplied by the bracket. So the inverse operation of multiplication is division. So if I divide this side by p, I have to divide that side by p, which would then mean my formula had become a over p is equal to, the p's have cancelled, and I'm left with 1 plus I to the power of n. Now we know most of our inverse operations. Let's just recap them here. The inverse operation of addition is subtraction. The inverse of multiplication, we've just used it over there, is division. But we must also remember that powers also have inverse operations. So the inverse operation of a power, I'm just going to write it down like this. The inverse operation of a power, in other words, when you've got an exponent, is the root. And if the power is squared, for instance, the inverse operation of squaring will be square rooting. The inverse operation of cubing will be cube rooting. The inverse operation of the nth power, in other words, something to the power of n, will be the nth root. So what I have to do now is I need to do the inverse operation of this. In other words, I've got to put that whole thing to the nth root, which means that I need to nth root this as well. So this side is going to become the nth root of a over p, and make sure that the entire fraction is inside the root sign to show that the a is being nth rooted and the p is also being nth rooted, otherwise it can become very ambiguous. Right, remember, because these are inverse operations, if I'm raising something to the power of n, but I'm also finding the nth root of it, those two operations cancel each other out. So I'm now just left with 1 plus I, which is fantastic because I'm trying to get the I on its own on one side. It is now almost on its own except for this 1. What's occurring between these two is the operations of plus minus. So remember your 1 here hasn't got a sign, so it's actually a positive. So when I take it to the other side, I'm still going to have this. It hasn't moved. And the positive 1 is going to go across the equal sign as minus 1. And then I now have my I on its own on one side. And once I've isolated the I like that and I've made it the subject of the formula, I'm able to substitute in the values of A and P, and I will then be able to find out the interest rate.